Okay, so today we're going to talk about the partial quotient model. It's going to connect to what we did with the area model yesterday when we were breaking down and decomposing our dividend into smaller numbers that are divisible by our divisor. It's going to look very similar to long division, but with a couple different changes. So what we're going to do is we're going to start with a little box that kind of looks reminiscent of what you would draw for hangman. We're going to put our dividend in the middle and our divisor on the outside. So you know that with long division, we used to put our answers up here and we'd subtract all the way down. It's very similar, but it's going to look just a smidge different. So with partial quotients, I'm going to start by asking myself, 5 times what is going to get me closest to my first 2 digits of my dividend, which is 56, without going over. Thinking aloud, I know that 5 times 11 gives me 55. If I were to go 5 times 12, that'd be 60. It'd be too many. So this is the closest that I can get without going over the first 2 digits. Now, with long division, you used to stop here and you'd bring things down, but this is going to look a little bit different. So what we're going to do is instead, we're going to fill this placeholder here with a 0 and add a 0 to the right over here. This is because 5 times 110 is actually 550, which is really the number that we're looking to get closest to. It's just easier to process it in your head to only look at the first 2 digits first and then add a 0 placeholder for the remaining 2 places. So now, just like long division, I'm going to subtract. So 2 and 1 and then a 0. So I'm not even going to put anything there. It's a placeholder. So now I'm going to ask myself 5 times what is going to get me closest to 12. I know that 5 times 2 is 10. So I put my factor of 5 over here on the right and what it equals in the middle, subtract it out, and now I'm left with 2. I know I'm finished because the number that I'm left working with is currently less than my divisor. This number, if it's not 0, if we have a number that's less than our divisor at the bottom, this number becomes our remainder. Okay? If you remember from yesterday when we did the area or the array model, our answer was always on the top and all we had to do was add our number up. Well, today our answer is just on the side. So now our answer is actually going to be 110 remainder 2. That should actually say 112 remainder 2 because I had to add my 2 right here to my partial quotient. Okay, we're going to look at another example. So here we have 841 divided by 6. So we're going to do the same thing. We're going to draw our big hangman. Our divisor, which is 6, goes on the outside, and our dividend, 841, in the middle. I'm going to start by looking at the first 2 digits because that's going to be the easiest to process in my head. 6 times what number gets me closest to 84? Now, with this one, just because our multiplication facts, we could sit here and count and see what factor is going to be closest to get us at 84. But we know that 6 times 12 is 72. And that's going to be probably the highest factor of 6 they know. And it's okay if they stop at something like 6 times 12, or really even 6 times 10. That's a friendly number. We don't want them to sit here taking way too much time to figure out what factor exactly is going to be the closest. We want them to be able to use numbers that are friendly, that they're not going to make a mistake and accidentally multiply incorrectly. So 6 times 10, they should know, hopefully, is 60. So they're going to go ahead and add these zeros here, because really I'm trying to get to 841, not 84. So when I add these 2 placeholders, I get to 600. 6 times 100 equals 600. So I'm going to subtract it out, and now I'm left with 241. Now here is where it's going to be easier to look at just these first 2 numbers. Now I have a 24 first. I know that 6 times 4 is 24, and I just have to add my placeholder, subtract them out, and I'm left with 1. Again, I'm left with a number that is less than my divisor, so I know I'm finished. The number remaining is my remainder. So now I just look to my right. 100 plus 40 is 140 with a remainder of 1. And one last problem. So this one, we're going to do 197 divided by 3. I know that 3 times 6 gives me 18, which is pretty close to 19. So I'm going to fill in my placeholders with zeros. because 3 times 60 is actually 180. Now I'm going to take 197 minus 180. I am left with 17. I know that 3 times 5 equals 15, with 2 left over. So right here, this is my remainder. My answer is on the right. These are my partial quotients. So I'm going to add them up. 60 plus 5 is 65, with a remainder of 2. There's no exact right way to do this over here. They can choose different factors, so they might be adding different partial quotients over here. As long as at the end of the day, once they have multiplied their divisor by the factor and subtracted it from our dividend, that they get down to the correct answer. If there's a remainder, then the remainder needs to be there. If there's no remainder, it'll just be 0. So if you have any more questions, please let me know. I'd be glad to help.